Hi and welcome. I'm trying to learn space science today, asteroids, and after we've done that, we're going to do shoulder impingement training. And if you participate in the shoulder impingement training, then it's better to be honest. Asteroids, solar system debris. Given the fiery birth of the solar system, it would be surprising if there were no remaining debris from that stormy period. Okay, what we're saying is it was a fiery birth of the solar system, so it was hot and explosive, whatever it was, all the bunch, all the, I don't know the vocabulary. And it would be strange if all would have cleared up and all the planets have taken all the materials to them. If Jupiter and the Saturn have got all the rocks, all the ice substances to them. If Earth, Mercury, Venus and Mars have taken all the solid metals and rocks to them. It would be strange if not some little crumbles were left in the whole solar system. And indeed, nearly 5 billion years later, the solar system is stuffed with leftover chunks of rock, metal and other materials. And yes, by saying here, there are a lot of cookie crumbles in our universe. So, it's full of little stones and rocks. These primordial fragments of a solar nebula are known as asteroids. And all of these leftover, not vacuumed up crumbles of rocks and metals are called asteroids. Asteroids have been known since 1801 when Ceres was discovered. So 1801, Ceres was discovered and it seems to be the first asteroid to be seen. Since then, astronomers have found more than 300,000 of them. Okay, 300,000 asteroids were found, and the first one found was Ceres 1801. Like Ceres, most orbit the Sun between Mars and Jupiter, forming a donut-shaped cosmic junk pile called the asteroid belt. Okay, between Mars and Jupiter, so yes, Mercury, Venus, Earth, Mars, and then Jupiter. Jupiter, Saturn, Uranus, and Neptune. So between Mars, so Earth, Mars, and Jupiter. Between Mars and Jupiter, there's the asteroid belt. And most of these asteroids are there. They are there in a donut-shaped cosmic junk pile. Like a donut around the Sun, called asteroid belt. Ceres is by far the largest at around 950 kilometers across. So Ceres is there, where it is around 1,000 kilometers across. We have it already on one previous part of planet business. The only asteroid large enough for its gravity to pull it into a sphere. I don't know what it means if an asteroid pulls something or itself into a sphere. But whatever, it is the only one with a size big enough to do a sphere. Only 3 others are larger than 500 kilometers. So there are actually not that much asteroids or something in the universe. There are just 4 ones who are bigger than 500 kilometers in diameter. 3 other ones are also there. The biggest one is Ceres 950. All of these are irregularly shaped. Okay, they are not almost completely round like Earth, but they are completely shaped like whatever. Like giant potatoes. Potatoes are not completely shaped. I don't actually know why it is. I think it is because if they're growing all in the plant in the ground, there are maybe other roots between them, or the earth at some places more hard. But I think the main reason is they're growing quite close together, all these potatoes, and I think they themselves coming against another one. But now why is no one stronger than another one? No, potatoes, they're growing in the ground, they're underneath the earth, and there's basically like a salad on top, but not like a farm salad. This is just whatever on top of the plants, the leaves, and then under the ground all of these little potatoes, they're growing bigger and bigger and bigger. Or they're starting to quite slow and getting bigger and bigger. And I think they're just crashing into each other, and that is why potatoes are not even shaped. But it's an interesting question, why are potatoes not round? I think it is because they're crashing into each other, but why do we not, or why are some potatoes stronger than another one? Maybe we've got more nutrients, but I think let's go back to space science. No, the asteroids are potato-shaped. Astronomers estimate that there could be as many as 25 million asteroids larger than 100 meters in diameter, so as big as a football or soccer field. There are 25 million of them. Do they say, which are as big as a football field. and fewer than 0.5% of which are larger than 1 kilometers. 1 kilometer, they said 1,000 kilometers, 500 kilometers. Okay, we're having the dates. There are 25 million football field size, 100 meters. There's 1 in 200, as big as 1 kilometer. So what is runnable in around 4 minutes? And if you run fast, and there are 4 which are bigger than 500 kilometers. Asteroids come in various classes depending on composition, but in general they are either carbon-rich, which is most common, stony or metallic. Okay, they are carbon-rich. I don't really understand still what carbon is. They have a carbon-rich, other ones are more stones or like metal. We know what they are made of because fragments of asteroids chipped off during collisions fall to Earth as meteorites. We have asteroids, meteorites, and also comets, and the other 2 shooting stars, which are meteorites, and meteorites, when you hit it out, meteors are shooting stars, and comets they have bigger elliptical orbits. And asteroids are the one just in the asteroid belt, and meteor if they hit the atmosphere, and meteorite are the smaller ones, meteorite if they hit the ground on Earth. I think it was a bit of us, but we have it on. Now, if these asteroids bump together and making smaller meteorites, and they're coming down to the Earth's atmosphere, and they're called meteors, and hitting ground, they are meteorites. They are leaving crater meteorite, not meteorite, meteorite. So asteroid, the big one, meteor. Asteroid, the big one, meteorite, the smaller pieces, meteor in the Earth's atmosphere, meteorite, with a T, the crater hitting the ground. And if someone analyzes now the meteorite, they find that they are carbon-rich, stony or metallic. Using sophisticated dating techniques based on radioactive decay, scientists have measured the ages of these samples to high precision, leaving no doubt that they are remnants from the formation of a solar system billions of years ago. So they took them and looked how old they are, and now we know that they are actually billions of years old from the time when the solar system formed. It might seem puzzling that the asteroids did not coal is some word, into a single planet. So they don't got together into the planet. And that seems strange. When asteroids venture too close to mighty Jupiter on the outer edge of the asteroid belt, they experience a gravitational tug. These asteroids then develop wildly elliptical orbits. Some are flung out of the sun. That took them in. We had another book, and there was written, some are, they used the word, not propel, they used the funny word, out of the asteroid belt and shot into the sun. Now, when asteroids venture too close to mighty Jupiter on the outer edge of the asteroid belt, they experience a gravitational tug. These asteroids then develop wildly elliptical orbits. Some are flung out of the solar system altogether, while others plunge into the sun. This constant gravitational bull-eyeing ensures that asteroids will remain, probably forever, individuals. Fossilized relics of the original solar nebula. Okay, the asteroid belt is between Mars and Jupiter, and they are just flying peacefully around there. But from time to time, they are coming a bit too close to Jupiter. Now, Jupiter pulls at them, like with its gravitation. And now when it pulls at them, they are, I think they're having 2 forces. They're orbiting peacefully around the sun, but now Jupiter comes. Maybe Jupiter is not all the time at the same. We have to know now where Jupiter is exactly orbiting. But Jupiter pulls at them and takes these comets away, but they're not, and they are somehow then pulled to some size. They're getting elliptical orbits, and now they're sometimes shot out of the universe or towards the sun or something else. Jupiter is taking them and distorting them into all directions, and maybe that is the reason. Are there coming meteors to the Earth which are which are not of the solar system? Imagine not. Then it's all the fault of Jupiter. Now Jupiter is pulling at them, and that brings them out of their peaceful orbiting around the sun, and they're shooting towards the sun or out into the universe. And if they're shooting towards the sun, it can happen that they pass along Mars, the Moon, and hit the Earth. Now, I think we have to talk about Jupiter a bit in a following part. If you were here for planetary now for space science, you can go directly to the next part of space science. If you are here for the short impingement training, then you can do it. If you participate in the short impingement training, then it's better to put it still stand and do short circles. Go back, up, front, down, back, up, front, and down. And again, front, up, back, and down. And now, long arms, strong fists, and go as far back as you can with the shoulders. Up, and front, down, and back, up, front, and down. And backwards. Up, back, down, front, up, back, down. And now, go a bit into the knees, hinge forward with a straight back, let the arms hang, pinch the scapulas together with effort. Make fists, lift the arms up and still pinch the scapulas together. Arms down, shoulders down, and then around into the knees, hinge forward, straight back, let the arms hang, let the arms hang, and pinch the scapulas together. Make fists, lift the arms up, pinch the scalp, shoulder blades together. Arms down, shoulders down. And again into the knees, next exercise. This time for round leg, bending forward, make fists, turn the fists to the inside, lift the arms high up, bring them together, straighten up, shoulders down and together. Arms high and together, shoulders down and together. And release. And again down, hinge forward, round arm, round back, let the arms hang, make fists to the inside. Lift the arms high up and bring them together. Straighten up, bring your shoulders down and together. And now lift the arms up. If this or any other exercise causes pain, then don't do it. And arms to the side and in front. And now we will lift the long arms, strong fists, shoulders down and together. Turn the arms to the other side, shoulders down and together. Arms to the outside, shoulders down together. To the inside, shoulders down. Outside, shoulders down. Release. Arms to the side, with fists in front, turning arms in front, shoulders down. Arms back, shoulders up, front. Change, arms in front, shoulders down, together. And release. Now a shrug, lift the arms up. Lift the shoulders up and let go down. Again, arms up. Shoulders up. Let go down. And last time. And now the pretzel cut, arms together, a bit down and to the outside. And again, down and to the and now with some diner. You can use a sock or something else. Have the long arm at the outside. Let it fall down and try to catch it again. And on the other side. Notched. I think I said notched. I don't know. Out of the asteroid belt and shot towards the sun. And the next exercise, we bring one arm from shoulder back and down. Pull the arm in, have the fingers, try to relax your arm, cover it back with shoulder down, down, to the sky. Upper arm in front. Shoulders back and down and pull the arm and have your fingers. Try to relax your arm. Send the power to the sky, cover it back. That was the short and training. I thank you very much and until next time.